Okay boys, we're back on the high voltage power supply again. I guess now this is like part 3. I've went ahead and added a few parts to this, but so just a recap. This big transformer here, this is the voltages that it produces. 2 yellows, 6 volt. Between the red and orange, it gives 125 volts, and between the two reds, it gives 250 volts AC. So, what I've got done right now, so I have it plugged in, so I've got to watch what I'm touching here, but she's turned off. So, what I've got done, I've got the circuit, the rectifier circuits straightened away here. So I'm using two diodes, and I'm using the center tap of the transformer for the negative side of the power supply. So basically the two diode rectifiers, each one of them are coming from each red wire, and this little schematic here is what I've got done. So we got the red wire here, we have the orange wire here. So with the two diodes, this is a bridge rectifier with the center tap transformer, obviously. So we have a 1500 UF, or should say 1500 microfarad, 250 volt capacitor put in here, and a 22,000 ohm resistor put right here, 22K. So you can see the capacitor and the resistor right here. So that is the rectifying the DC side of the power supply. Now, without the capacitor in line here, off the two diodes right here, between the two diodes and orange, I get about 110 volts DC right here. Now after I put in the capacitor, which bumps up the voltage a little bit, now I get about roughly 168 volts DC on the output, on the capacitor. Now, here's a question for you guys. I have a 22K resistor, 22 ohm resistor. She sits right here on the capacitor, electrolytic. She's right here. 22K, I already checked with the ohm meter. It's actually still a good resistor. But it's 22K. What would be the purpose of that 22K resistor? Putting it across the electrolytic capacitor. So just think about that for a minute. What is the purpose of having that resistor sitting across that electrolytic capacitor? I'll let you think about that for a minute. Okay, long story short. So, as you know, electrolytic capacitor holds a charge, holds a voltage. So, if I've got 110, 115 volts going into this electrolytic capacitor, the capacitor can safely hold, or can work, up to, but no higher than 250 volts. So the capacitor can hold a charge of 250 volts maximum voltage before she goes bang. So the purpose of the resistor is when the power supply is on, you'll get the voltage. You get the full voltage, 168 volts, 168 volts, whatever, off the capacitor, off that little electrolytic. Now, when you turn off the power supply, of course you got your terminals there, you know, what would the capacitor would still hold that same amount of voltage unless there was some way to dissipate the voltage, to bleed off the voltage. And that is the purpose of that resistor. It's known as a bleeder resistor, and it does exactly that. It bleeds off the voltage of the capacitor to ground to basically take the voltage build up in the capacitor and drop it to zero when the power supply is turned off. That's the purpose of this resistor. It's a bleeder resistor. It bleeds off the voltage. So I'm just going to show you an example of what happens when the power supply is turned on. So we got the meter here. We're going to turn the power supply on. So the power supply is on right now. I'm going to take my probe very carefully, put it here, right there, and we've got 163 volts. Now I'm going to turn off the power supply. I'm going to turn it off. And what do you think is going to happen at this voltage? Well, just watch this. That resistor, which is right there, is bleeding off, safely dissipating the voltage to ground. Anywho, so since the last time I spoke to you, in the little clip before this one, before the phone rang, thanks Thomas. Yeah, where was I? Oh yeah, I installed a terminal strip out front, this one here, nice heavy plastic one. So basically what I got here, I have the filament supply, 6 volts right here, and then I have the ground, or the negative, 163 and positive 263 here. So, right there. Now I've read in a book, magazine, PDF document, website, whatever, somewhere, I haven't got a clue where, but the last little few tube radios I built, I always just get a hum, a little bit of a hum on the audio, and I can never figure out why, even though I've got a filter in it. And I've read that if you take the filament supply voltage wires and you twist them like this with your drill right here, and you twist them like that, that it actually cuts down on the hum. I don't think it completely eliminates it, but it do cut down on the hum quite a bit by twisting the wires like that. I never knew that, but now we do. So this is the supply. Just turn the voltage on here, turn the power supply on, and we have 158.4 volts. It's right off the terminal strip right here in the front. So we got the 2 diodes right here, filter capacitor. It's a very basic power supply, very basic, but it does the job. Bleeder resistor over there, of course, and my fingers are quite a nice ways away. But there she be. Now I've got to come up with a piece of black plastic to cover up this big gaping hole in the back of the unit. So, and I'll be removing these binding posts. They're not staying there. They're not needed. But anyway, there we have it. So now we'll just turn off the power supply, and the voltage will drop out with the bleeder resistor. So again, it's 22K. So I think this thing was a success in building this. As she sits right now, this is the schematic for this power supply as she sits right now. So there we have it. Alright, well, if you got any more suggestions or comments you want to say about this power supply, well, post them below. We can see what else we can do. I'm also thinking, see what I should have did, if any time back, when I cut this terminal strip, instead of cutting it before, I should have cut it to 6, because then I could have had a 6 volt filament and a 12 volt filament, 12 volt and 6 volt. All I'd have to do was install a 12 volt transformer in here to give a 12-volt filament voltage, heater voltage. Anyway, maybe I'll do that later. Anyway, folks, this is part 3 of the high voltage power supply. Alright, got any ideas, suggestions, whatever? Post below. Let's see what else we can do with this thing. All the best, folks, and 73, Mr. Radionuts 63. We're out of here.